want to prove that cosine of theta divided by 1 plus sine theta is equals to 1 minus sine theta divided by cosine theta. So we want to prove that the left hand side of this equation is equal to the right hand side. So we are not just going to use both of them at once, okay? We will solve one of them and make it look like the other. So at this point, let's use the left hand side. We can as well use the right hand side conversely, but I'll do this and I'll allow you to use this side. Okay, over to this man right here. To use cosine theta divided by 1 plus sine theta, I'm going to apply a technique by saying multiply numerator and denominator by the conjugate of the denominator. So this should just become 1 minus the conjugate of this man right here is negative instead of positive. 1 minus sine theta divided by 1 minus sine. Now, if this and this cancel out, we are still left with the initial expression. So it doesn't change anything, okay? So we're just going to multiply this way, multiply this way. So we're going to have cosine of theta times 1 minus sine theta, okay, divided by, now you notice, okay, this and this forms what? Difference of two squares. When we say 1 times 1 is giving us 1 square, and we have 1 times negative sine theta is giving us negative sine theta. Sine theta times 1 is just giving us, okay, so we have negative sine theta. Sine theta times 1 is giving us positive sine theta. So here we'll be having sine theta times negative sine theta is giving us negative sine square theta. And you observe that this and this are equal and opposite in sign, so they will cancel out and we'll be left with 1 minus sine square theta. Okay, so I can just write it that way. 1 minus sine of square theta. Okay, so from here, I would observe that this denominator right here, 1 minus sine square theta, is the same thing as saying cosine of square theta. Alright? Yes, from our basic trig identities, we know that 1 minus sine of a square angle is something as cosine of the square of another angle. Okay, so we still have our numerator with us, cosine of theta times 1 minus sine theta. Okay, so there can be a cancellation here where this will cancel one of these and we'll be left with just this 1 minus sine theta. You know, this one was square, so one of it is remaining, so we still have cosine theta, and this is this right here. So we've shown that the left hand side of this equation is equal to the right hand side. You can also show from the right hand side, proof to get the left hand side by just applying the same technique. Okay, now over to the next proof. Here we want to prove that sine of a plus b minus sine of a minus b is equals to 2 cosine a sine b. Now we'll be doing this using our trig identity, which states that sine of a plus b is equal to sine a cosine of b, okay, plus cosine of a sine b. So the same thing for this man right here, we're going to have sine of a minus b to be equal to, take note, since this place is plus and this place is minus, so the sign that will just change it is from plus to minus. So we have sine of a cosine of b minus cosine of a sine of b. Now notice this, okay, I believe you've done this already. Now this is true, so we're just going to apply this right here and we evaluate this expression, sine of a plus b, which is this man right here, minus this guy. So just this one minus this one. Okay, so what if I just start at once, I group this one to become a single term and I subtract this guy from it, minus this. So if you just look, you have sine a cosine b minus sine a cosine b. The result there is what? Just 0. We go again, positive cosine a sine b minus negative of this. That is just cosine 0 plus cosine a sine b minus a negative of, cosine A sine B. Right. So here we just have negative times negative, that resolves to what? To positive. So we have this and this are the same. So we are adding them, then we'll simply have 2 cosine of A sine of B. That is our right hand side. So therefore this has been proven.